Assalamualaikum everyone. I'll share the process of creating this vortex with geometry node inside Blender. I made this vortex for a custom mocker project where the particles needed to move along the surface of a second object when they appear on a particle flow. And geometry node gives me the options for precise controls. Alright, let me begin with a fresh Blender file. I will use a plane as an emitter for particle flow. I will make the particle flow horizontally, so rotate it to 90 degrees on y-axis. Let me resize the plane. Now add geometry node. Add distribution points on faces. I am using the Blender version 4.2. So it has a simulation zone node and I will use that to move all the particles. So at simulation zone, there's no need to connect the output of distribution points to simulation zone. Rather, I will use a join geometry node inside simulation zone and connect the simulation zone's first node and distribution points node. This will keep spawning the points on the plane. Now, to move the particles, add set position node. I need to store the points normal before simulation. So, use store named attribute node, set it to vector, or connect to the normal and geometry sockets. I will use this normal to move the added points, so the points will move in the direction which the plane is facing. Now, add a named attribute node and connect it to the offset in set position. We can use vector scale in between to control the speed. Here, inside simulation zone, the movements are dependent on the frame rates. So, if the frame rate is 24 fps, the speed will be less than what the speed is at 30 or 60 fps. To keep it consistent across all frame rates, we can use delta time of the simulation zone to scale the speed. So, let's add the delta time to vector scale, and to have a control over speed, we can add a math multiplication node in between. Let me bring up the timeline tab and set the end frame to a large number. Alright, the points are moving, but to make it more organic, I am going to add some randomness to their movements. I am using random value node and scene time node to change the seed, and also add the frame input to the seed of the point distribution node. Next, I will work on the vortex. Let's add a V-sphere. It will act as the center of the vortex. I am going to use the tangent of this sphere for vortex torsion. To get the tangent, we can use direction vector of the points to the sphere faces. Subtracting the positions of 2 points will give us the direction vector, and then cross product of it to a rotation axis. In this case, I will use the position of the points and position from the proximity node. First, let's store the position of the points in the simulation zone. Name it as a point underscore pose. It will keep updating the position of the particles in each cycle. Now, use the named attribute node, set it to vector and use the earlier stored name point underscore pose and subtract this proximity position from the position of the points. It will flip the direction vector. Also connect the point position to sample position. We will need to normalize it, otherwise it will just burst out from the center. Next, add a vector math node and set it to cross product. I will use the second input of cross product to set the axis manually. The axis you want the vortex to rotate X, Y or Z, set it to either positive 1 or negative 1. Positive and negative value will determine the direction of vortex rotation. I want the particle to rotate on Z-axis. So set the value of G to 1. Keep in mind that this axis is local axis of the plane or the emitter. So you might need to apply the rotation of the plane to align with the global axis in this scene. And this cross product will be our main vortex. Now I will divide 1 by the proximity distance. It will give us a value that decreases gradually the further the points are from the center. Now multiply this with the cross product. Add this result to the position of the points and connect it to a set position node inside the simulation zone. The vortex is almost done. We can keep the force of vortex updated for each frame by storing it as an attribute prior to the set position. So, store the name attribute and use named attribute node for the addition. This blend file will get slowed down or crash from continuous spawned points. So we can set a point deletion system similar to bounding box beyond which points will get deleted or destroyed. I will use a plane for this. So let's add a plane and resize it. Bring it inside geometry node and add a proximity node. Subtract the position from the proximity position. We can get a distance from this subtraction and use it to compare between points position and plane's phase with dot product. Now add a delete geometry node and connect the compared result to its selection input. We can use the compared C value to set a distance from the plane to delete the points. Finally, I will add some controls to adjust the radius and force intensity. For this, I will use map range nodes to proximity node and mix it with vortex force. In my previous shots and when I implemented this node setup for the first time, I had used this a bit complicated control method with two map range nodes. But I think this one that I am going to show will be more simplified method with more ease of control. So add a map range node from proximity distance and set it to smoother step. Set this max value to 0 and min value to 1, and the upper values will control the force blurriness. I am going to keep the min value to 0 and max value to 5. Add a math multiply node in between to control the radius. Then vector multiply it to the normalized direction. Now bring up the named attribute, set it to vector and use the named force. Add it to multiplied result. And then finally add the point position to it. This will go to the position of the set position node. Now let me show how we can use this setup for multiple vortexes in different direction. Let's add another sphere for second vortex. Let me add a group with these nodes. This group node will be duplicated for the second vortex. Let me add a group input for the direction. Join those two spheres with join geometry. Connect it to proximity node. Duplicate the proximity node for each sphere and connect the distance output to the node group. Now duplicate the store named attribute for force and connect the second vertex node here. Add these forces with vector math and with the point position. Now we can use these spheres to add multiple objects with geometry node or even use simple modifiers for abstract arts. For texture, I am going to use proximity distance and stored named attribute. I am using cycle render, so not adding any instances. For EV, you can just use any instances and follow the same method to store named attributes for texture. Let's bring up the shader tab, add attribute node, copy paste the attribute name from geometry setup, add a map range node, do the same for other vertex, and we can use these map range nodes in mix factor for different materials. Don't forget to set material node in geometry setup. It's a simple setup and easy to use. I should mention that this simulation is mostly effective for larger objects or vortex. For smaller objects, I was facing problems with tangent calculation. Could be due to difference between smaller face area versus point radius, but again the smaller points are almost invisible, and if I push the density as Blender uses CPU calculation, it will tank the CPU usage and slow down the whole process. So it is what it is. Just like other simulation, it might be possible to bake and scale down the final simulation as well. Anyway, this blend file with optimized and arranged node setup will be free to grab in Gumroad or somewhere online. Link will be added in description. If possible, I will upload this complicated version that I have been using in my Patreon. So, see you next time for this node.